It's been a long time that I made a last video, and this time I'm again presenting this PWM controller. It's a PCA, and I'm controlling up to 16 different gadgets like servos or simple motors, and this simple motor I am controlling with a high power MOSFET transistor, and I'll show you how I did it. Okay, so at first the servos are just connected via normal servo cable, and the high power MOSFET about the same with a little bit difference. I just connected with these stickers, but I will also use this servo cable to solder the MOSFET to it. So I am having the MOSFET here. It is a IRF for 540N, and you basically use them the following way. The left connector is your gate, so through the gate there is no current floating. It's just measuring the voltage at the gate. It's measuring the gate source voltage, and as soon as the gate source voltage exceeds 3.7 volt, the transistor is giving power through the drain. So you see the drain is directly connected to the motor. So I have the following setup. I have the ground cable going through the source, then continuing to the drain. The drain goes into the motor and to VCC 5 volts. I could also put another voltage here, like 12 volts or 100 volts. The MOSFET is up to 100 volts. And put any motor that can handle 100 volts. And the only thing I have to consider is that I can still have this 3.7 gate source voltage. How do I apply the gate source voltage? I'm doing it with two resistors. A resistor with high resistance, it's like 220 kilo ohm, is pulling this pin to the ground, so it has a potential of 0 volts. And then a 10 kilo ohm resistor, so a lot smaller resistor, is pulling it towards 5 volts with this pin of the PWM controller. So as soon as the PWM controller has a voltage potential, it pulls this pin up to like about 4 or 5 volts, and this is enough to switch the transistor on. Now let's take a look at the code. I'm having my script, which is basically using this library, so you can install it with pip, sudo pip install Adafruit circuit python PCA 9685. PCA 9865 is also the name of the PWM controller, so you can find it on eBay using this name. Then I'm importing this library and also SCL and SDA and bus IO. Then I am creating my I2C bus by using bus IO, using the GPIO pin 2 and 3. So basically it's very simple, just these 4 cables on the Raspberry Pi. I had to enable I2C on my config file, of course. Then I'm using the library to create my handle object. And then I am setting a PWM frequency. So PWM means pulse width modulation. So the PWM controller spins in a frequency of 50 Hertz. And 50 Hertz means every second there are 50 cycles. And each channel you have a duty cycle. And the duty cycle is a fraction of, in this library at least, of 0xFFF. So a 16-bit number that tells you how bright the LED should be, or in this case you use it to control the throttle of the motor. Like on channel 1 I'm using the motor throttle, so I'm having a 0, a 0.5 and a 1.0. This is the 3 motor throttles. And for the servos, I'm using a different trick. I am dividing the maximum through 20. So if I have 20 times 50 is exactly 1,000. So 1,000 milliseconds. So if I divide the total through 20, I get exactly a pulse width of 1 millisecond. And if I multiply it with 1, I get 1 millisecond pulse and then 19 milliseconds pause. So with 50 Hertz, each cycle lasts 20 milliseconds. And if I divide the cycle length through 20, I get the cycle length of 1 millisecond. This 1.5 milliseconds is the neutral position of the servo, and the 2.0 is the maximum servo position. So I'm just toggling the values from leftmost neutral position and rightmost position in an eternal loop, with each cycle lasting 1 second. The cool thing is that this PWM controller does hardware PWM, so you don't have to care about CPU load or anything. It just gives you a stable PWM signal.